Hey guys, happy Tuesday. I hope that your week is off to a good start and you're ready to continue talking about probability today. So, we are going to look at the difference between experimental and theoretical probability. So, the best way for me to explain this, I pulled out the notes from our normal notes pages, and you don't need to write this down or anything, but we're just going to kind of talk about it. And then I'm going to show you an example with rolling a dice. So, experimental probability is the ratio of the number of times an event occurs to the total number of trials. So, that's what does happen. That's a real world example. And I'm going to talk about that in just a second. Theoretical probability is the probability of an event happening based on the possible outcomes. So that's what should happen. It's a perfect world example. So, talking about some of the probability situations we talked about last week, like flipping a coin or rolling a dice. Flipping a coin, the probability of getting a heads would be 1 out of 2. Probability of getting tails would also be 1 out of 2. But if I flip a coin and I flip it twice, am I always going to get 1 heads and 1 tails? No. So theoretically, I should get 1 heads and 1 tails if I flip my coin twice. But experimental probability is when you actually do the experiment. So the real world, you actually flip a coin 10 times. If I flipped a coin 10 times, theoretically, I should get 5 heads and 5 tails because I have an equal chance of getting both. But if I flip a coin 10 times, I'm not guaranteed to get 5 heads and 5 tails. So theoretical is like in a real world perfect situation based on the likelihood, what should I get? Experimental is actually doing the experiment, which makes it easy to remember. So for my next example, I'm going to talk about rolling a dice like we did last week. Theoretical probability, the probability of that's what you did last week. The probability of getting a 1 is 1 out of 6 because there's number 1 on a dice. Probability of getting 2 would be 1 out of 6, again, because there's only 1, 2 on a dice out of 6 possible options. Probability of getting 3 or 4 would be 2 out of 6, because I would put 3 and 4 together, which simplifies to a third. And then probability of not getting a 5. That means I count all the sides that are not a 5, and I get 5 out of 6. Now, that's theoretical. That's in a perfect world based on the number of possible outcomes and the number of your event on your dice. Now, for the experimental, I rolled a dice 30 times, and I really did do this. And I got 2 1s, I got 5 2s, I got 3 3s, I got 9 4s, I got 4 5s, and I got 7 6s. So all that should add up 10, 9. Yes. Okay. So all that adds up to 30. I rolled it 30 times. So my frequency is how many times that number actually showed up. And then my probability, I would put 2 out of 30 because it showed up twice out of 30. And then I could simplify that to 1 out of 15. 5 out of 30 would simplify to 1/6. 3 out of 30 would simplify to 1/10. Move my little picture here. It'll let me. Nope. It might not let me. It did the other day, but I'm not sure how I did it. Okay, anyway. Let's see. 4 was 9. Oh, wait. 9 out of 30, which would simplify to 3/10. 4 out of 30 would simplify to 2 out of 15. And I know you can't see that, but when you get to your slides in a minute, all of this is going to be on there. Oh, here we go. I can move it now. And then 7, or for 6, I had 7 out of 30, which cannot be simplified. So now looking at these probabilities, I can compare them. So, like the probability of getting 1 was supposed to be 1 out of 6, but when I did my rolling, I only got 1 out of 15. So that's actually less than what the theoretical probability. I should have had 5 for each one of these because 30 divided by 6 is 5. So I should have, so this is less. This is exactly 1/6. So that matched up perfectly, but that's the only one that did. So this is the actual experiment where you try some trials and you see what you get. And then you can compare them to theoretical probability. So now you're going to, the instructions are all here on your slides, but I'm going to go ahead and explain it to you. You're going to take a piece of paper and cut out 10 squares and then color them in. If you can't find colors or markers or whatever, just write the words yellow, green, red, blue. So you're going to do 1 of them yellow, 2 green, 3 red, and 4 blue. Then mix them all up in a pile, or you can put them in a Ziploc bag or a brown paper bag, whatever you have. And then without looking, I want you to draw one out at a time. And you're going to do this 30 times and then record your data just like I did with my dice, even though I didn't show that on camera. So you're going to record it on your sheet, what you get each time. If you get a red, if you get a green, if you get a yellow. And then you're going to answer your questions here. So the theoretical, you're going to do exactly what I just did. Let's see if I can move this again. The theoretical data is going to be in a real world perfect situation. What's the probability that I should get green? Well, there's 2 green out of how many total? 10. So this would be 2/10. And you can leave it like that, or you can simplify to 1/5. Either way is fine. And so then you're going to answer those 2. And then here, you are going to show me your data. So however many times you got yellow, you're going to put that here. However many times you got green, red, blue, and then write it like a probability. So this number, the frequency out of the total, which the total should be 30 because you're going to draw them out 30 times. Okay? And then that's it. This is your short assignment for today. And then go ahead and jump and do lesson 2. I would do them right back to back if you have the time for it, because it's not going to take you very long and they go hand in hand. These 2 lessons do. So jump into the second lesson when you finish this if you have the time. I'll talk to you guys soon. Send me an email if you need help. Bye.